Hi, welcome to my channel. In this video, we want to find k and d such that the system of equations y cubed minus x cubed equals 16 and y equals kx plus d has no real solutions for x and y. And now for the solution. First, let's call the equation y cubed minus x cubed equals 16 as equation 1 and the equation y equals kx plus d as equation 2. Next, we substitute equation 2 into equation 1 to obtain kx plus d cubed minus x cubed equals 16. We expand kx plus d cubed using the identity a plus b cubed equals a cubed plus 3a squared b plus 3ab squared plus b cubed. For our case, a equals kx and b equals d. Following this, we use the identity ab to the power of n equals a to the power of n times b to the power of n to write kx cubed as k cubed times x cubed and this term as 3dk squared x squared. After rearranging the terms, we obtain k cubed minus 1 x cubed plus 3dk squared x squared plus 3d squared kx plus d cubed minus 16 equals 0. A cubic equation always has at least one real root. Therefore, we require the coefficient of x cubed to be 0. This implies k cubed minus 1 equals 0 or k cubed equals 1. Taking the cube root of both sides, we get k equals 1. Substituting k equals 1 into the equation, we get 3dx squared plus 3d squared x plus d cubed minus 16 equals 0. When d equals 0, the equation reduces to minus 16 equals 0, which is impossible. Therefore, the system of equations has no solutions when d equals 0. So one possible value of d is 0. When d does not equal 0, the equation is a quadratic equation. Recall that for a quadratic equation, ax squared plus bx plus c equals 0. To have no real solutions, the discriminant b squared minus 4ac must be negative. Here, a equals 3d, b equals 3d squared, and c equals d cubed minus 16. Writing 3d squared whole square as 9d to the power of 4, and then expanding this term gives us minus 12d to the power of 4 plus 192d. After combining like terms, moving the terms to the right hand side, and then dividing by 3, we obtain d to the power of 4 minus 64d is greater than 0. After factoring out d and writing 64 as 4 cubed, we can use the identity a cubed minus b cubed equals a minus b times a squared plus ab plus b squared, where a equals d and b equals 4. This gives us d times d minus 4 times d squared plus 4d plus 16 is greater than 0. Let's examine the term d squared plus 4d plus 16. We can rewrite it as d squared plus 4d plus 4 plus 12, recognizing the term in the brackets as d plus 2 squared. Therefore, the term is always positive. Dividing the inequality by this term, we obtain d times d minus 4 is greater than 0. From the graph of the function, we find that the function is positive when d is less than 0 or d is greater than 4. Therefore, the solution to the inequality is d less than 0 or d greater than 4. Combining this with the earlier results, we find that k equals 1 and d is less than or equal to 0 or greater than 4, which is the solution to our problem. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.